The sun feels ordinary because it has always been there. Every morning it rises, every evening it sets. It gives Earth light, warmth, weather, seasons, and life. But the sun is not an ordinary detail in our sky. It is the reason Earth is the way it is. Our planet orbits at just the right distance from a star that is stable, bright, and calm enough for life to exist. But what if the sun was replaced? Not by darkness, not by nothing, but by another kind of star, a smaller star, a colder star, a hotter star, a dying star, or something far more extreme. Would Earth survive? Or would our world become completely unrecognizable? To understand this, we have to remember something simple. Earth is not just orbiting a ball of light. It is orbiting a source of gravity, radiation, heat, and time. Change the star, and you change almost everything. The first possibility is a red dwarf. Red dwarfs are the most common stars in the galaxy. They are smaller, cooler, and dimmer than the sun, and they can live for trillions of years. At first, a red dwarf might sound like a good replacement. It would last far longer than our sun. It would burn slowly and steadily. And in theory, a planet could still have liquid water. But there is a problem. A red dwarf gives off much less light and heat. If Earth stayed at the same distance it has now, our planet would freeze. Oceans would turn to ice. Photosynthesis would collapse. The atmosphere could change dramatically, and Earth would become a cold, dark world. To stay warm, Earth would need to orbit much closer to the red dwarf. But that would create a new danger. When a planet orbits very close to its star, the same side may always face the star. This is called tidal locking. One side of Earth would live in permanent daylight. The other side would remain in permanent darkness. The day side could become hot. The night side could become frozen. And life would have to survive in the narrow region between them. Red dwarfs can also produce powerful stellar flares. These bursts of radiation could strip away atmospheres and damage life on the surface. So even though red dwarfs live for an incredibly long time, Earth around a red dwarf would not simply be a peaceful version of our world. It would be colder, stranger, and far more unstable. The next possibility is an orange dwarf. Orange dwarfs are smaller and cooler than the sun, but not as extreme as red dwarfs. Some scientists think they may be among the best stars for life. They live longer than stars like the sun. They are more stable than many red dwarfs, and they can provide steady light for billions and billions of years. If the sun was replaced by an orange dwarf, Earth would still receive less energy than it does today. At the same distance, the planet would likely become cooler. Winters would become harsher. Ice could spread. Weather patterns would change, and ecosystems would be forced to adapt. But compared to many other stars, this might be one of the least catastrophic replacements. If Earth's orbit moved closer to the orange dwarf, the planet might remain habitable. The sky would look different. Sunlight would appear warmer and more orange. Plants might evolve to use the new light in different ways, and the rhythm of life could change. Earth would no longer be the same. But under the right conditions, it might still remain alive. Another possibility is a star very similar to our own. A yellow dwarf, almost the same size, temperature, and brightness. At first, this might seem like nothing would change, and compared to every other option, that might be true. Earth could remain warm. The oceans could stay liquid. The sky could look familiar, and life might continue. But even small differences matter. If the new star was slightly brighter, Earth could warm. If it was slightly dimmer, Earth could cool. If it was more active, solar storms could become dangerous. If it was older, it might be approaching the end of its stable life. Earth is balanced around the sun we have, not just any star. Now imagine replacing the sun with a blue giant. This would be one of the worst possibilities. Blue giant stars are massive, extremely hot, and incredibly bright. They burn their fuel quickly. They blast out intense ultraviolet radiation, and they live short, violent lives compared to stars like the sun. If a blue giant replaced the sun at the same distance, Earth would be overwhelmed. Its stronger gravity could also disturb Earth's orbit. The surface would heat rapidly. Oceans could begin to boil. The atmosphere would be blasted by radiation, and life on the surface would be destroyed. The sky would burn with a harsh blue-white light. Daytime would become dangerous. Temperatures would rise beyond anything humans could survive, and the planet could lose much of the balance that makes it habitable. To survive around a blue giant, Earth would need to orbit much farther away. But even then, it would face problems. Blue giants do not last long. A star like this might live only millions of years instead of billions. That sounds like a long time to us, but for life, evolution, and stable climates, it is very short. A blue giant would be powerful, beautiful, and deadly. It would give too much light, too much heat, too much radiation, and too little time. Another possibility is a red giant. A red giant is not a young star. It is a star near the end of its life. One day, our own sun will become a red giant. It will expand enormously. Its outer layers will stretch outward, and the inner solar system will be transformed. If the sun was suddenly replaced by a red giant, Earth could be in immediate danger. The star might be so large that it would reach close to Earth's orbit, or even beyond it. If Earth was inside the outer layers of the star, it would be destroyed. If it was not swallowed completely, it would still be scorched. The oceans would evaporate. The atmosphere would be stripped away. The surface would become lifeless. A red giant is cooler on its surface than the sun, but it is enormous. That size makes it incredibly luminous. Even if the light looks redder and softer, the total energy could be devastating. Earth around a red giant would not be a peaceful red sunset. It would be the final stage of a dying star. Now imagine something much smaller, a white dwarf. A white dwarf is the dead core left behind after a star like the sun has finished its life. It is small, dense, hot at first, and slowly cooling over time. If the sun was replaced by a white dwarf, Earth would be thrown into a very strange situation. At the same distance, Earth would receive far less light and warmth. The planet would freeze. The oceans would become ice. The surface would grow dark and cold, and life would collapse almost everywhere. To receive enough warmth, Earth would need to orbit extremely close to the white dwarf. But that orbit could be dangerous. The planet might be tidally locked. The star's gravity could create strong tidal forces, and any leftover debris around the white dwarf could pose a threat. There is another problem. A white dwarf does not shine like a normal living star. It is a fading remnant. It can still give light and heat, but it is not the same kind of stable, life-supporting star that Earth has today. Around a white dwarf, Earth might survive physically, but it would not be the Earth we know. And then there is one of the most extreme possibilities, a neutron star. A neutron star is the collapsed core of a massive star after a supernova. It is incredibly dense, small, and dangerous. A neutron star can have more mass than the sun packed into a sphere only about the size of a city. Its gravity is extreme. Its magnetic field can be enormous, and it can release intense radiation. If the sun was replaced by a neutron star, Earth would not become a normal planet orbiting a small, bright object. It would enter a nightmare. The light and heat would be completely wrong for life. Radiation could sterilize the surface. The gravitational environment would be dangerous. And if the neutron star was a pulsar, powerful beams of radiation could sweep through space like a cosmic lighthouse. Earth might remain in orbit, depending on the exact mass, but orbiting is not the same as surviving. The planet could be frozen, irradiated, or stripped of its atmosphere. A neutron star would not be a replacement sun, it would be a cosmic hazard. This is what makes the question so important. The sun is not perfect because it is special in a dramatic way. It is perfect because it is stable enough, bright enough, calm enough, and long-lived enough. It gives Earth time. Time for oceans, life, evolution, forests, animals, and eventually humans. A red dwarf might give too little light. A blue giant would give too much. A red giant would come too late in a star's life. A white dwarf would be only a fading remnant. A neutron star would be far too extreme. A sun-like star might be the safest replacement, but even then, small differences could change Earth. And an orange dwarf might work, but only if Earth's orbit changed. The truth is, Earth is not just lucky to have a star. It is lucky to have this kind of star, at this distance, at this moment in time. If we replace the sun with another star, Earth might survive in some cases, but it would not remain the same. The light would change, the weather would change, the oceans would change, the sky would change, and life would be forced into a new world. The sun feels ordinary because it rises every day, but maybe that is what makes it extraordinary. Not that it is rare, not that it is the biggest, hottest, or brightest star, but that it is steady enough for a planet like Earth to call it home. Thank you for watching.